Hello, my name is Ale Pagan, and I'm here with Alanis Negroni. I'm going to be talking about Project 2, Protocol Analysis Design and Management. I'll leave you with Alanis, but she's going to explain Section 2 and Section 3 about the project.
So yeah, for the protocol we're working on is the stop and wait protocol, which has the following three layers. We have the application layer that handles the user input and message transmission. We have the data link layer that is responsible for framing and sequencing and retransmissions. And we have the physical layer that simulates network transmission, including the possibility of packet loss. Then, as part of these of the layers, we modify the physical layer in which we enhance the transmission functions to simulate more realistic network conditions. We introduce a 10% chance of packet loss, a 5% chance of packet duplication, and random delays of up to 2 seconds. So these modifications mimic real-world issues such as congestions and unreliable connections, providing us with a controlled environment to test error recovery and performance. So as part of the data link layer, we have a state machine to manage packet transmission. There are two main states. We have the state ready to send, that the system is, which means that the system is ready to transmit a new message, and we have the state waiting acknowledgement, which means that the system is waiting for acknowledgement after sending a packet. As part of the transitions, well, we have various events to get state transitions, such as the open layer requesting transmission, the arrival of data packet, or a timeout. The fin state machine ensures reliable messaging delivery through retransmission if necessary. Now I'll leave you with my partner, ALP.
Nice. So yeah, so a quick recap of what Alanis said. We modify the probability that a package gets duplicated and the probability that a package get lost. So I'm going to show you that real quick here. And uh, so yeah, so here we see that we are first checking if there's a chance for the packet to be lost, and if it's not, then we also check if there's a chance that the packet be duplicated. So and if we do, then we just send it once and then the second time to be duplicated, and also we introduce a delay from like nothing, which is a delay from zero up until like 2 seconds, and uniform just means that it goes from zero all the way to the floating point until two. So yeah, so as we can see the output here, if we write Alice to Bob, and then we do send, we can see that as of now we don't have any packet loss or any packet duplication. So let's do that for the same with Bob to Alice here real quick. However, we do see that we have an error that it has to resend the refrain. So I'll keep doing this until we see a packet loss or a packet duplication, just so we can see the both errors. Off to Alice. Again, so our point what we're trying to do is just check that we see a duplicate or a packet lost print, so that we can make sure that it's actually working before moving on. Yeah. Again, so the probability is not that high, so I'll probably be here for a while, but I'll keep doing it until we do. Oh, as we can see, finally we got a packet loss, which is only a 10% chance. For the packet duplicated, we have only a 5% chance that we get to see it. So in this case, I'm gonna skip over it. But as we can see right here, um, it is implemented. It's just a low chance in duplication that it might not see in the video. So yeah. So moving on, another part of the code that we wanted to modify is to add a measurement layer, which just tracks what we know. So where we can see that we have like a total expected where we want to send 100 packets. We have like a duplicate tracker, all the messages that we've seen, just to make sure that have like a dictionary of the messages, the packets that already you have seen. the delays that we have seen before and all that. Also the experiment ID if we're on experiment 1 or experiment 2, just to keep that for the prints. Finally, this is all the workflow, the calculating the metrics, the loop, which just stands by the application layer and the physical layer and just with it. Yeah. So I'm gonna run through the example real quick here. So you can see that as soon as we see all the data here, all the packet loss, the packet duplication, the packet loss again. So we see that we have a various times that we lost packet, and as you can see, we have an average delay of 3 milliseconds, and message loss rate of 3%, and duplicate message rate of 3%. And now for experiment 2, just a recap, experiment 1 with 2 nodes, 2 layers, which is the measurement layer over the physical layer, and the experiment 2 is basically the 2 nodes and 3 layers, which is the measurement layer over the data link layer over the physical layer. So we can see here, it does all the workflow where it sends all the packets. And finally, we have an average delay of 2.3 milliseconds, and message loss rate of 2%, and a duplicate message rate of 2% also. Yeah. So that will be all for the Stop and Wait protocol. Another thing that we do in this project is test for network performance using iPerf3, which is a tool written in C. And I'm gonna demonstrate how it works real quick here. So as part of the project, one of the first steps is first you need to set up a local iPerf3 server, which right here I'm currently just gonna test like this. This is what it's doing is I'm using the iPerf3 tool to connect to my local host machine using the UDP protocol. I'm going to do the same thing, but without using the UDP protocol, using the TCP protocol. So as you can see, we have different statistics, transfer, bitrate, jitter, and loss in total datagrams for the sender and the receiver. So I'll do the same thing for TCP, which is ignore the -u flag. So this is a TCP network test performance for my local server. Let's see until it finishes. Yeah, and finally we have that it didn't like lost any kind of data because again it's like the local machine server, so it's not really a network performance test. It's a memory and CPU test. So now to the real test, what we're going to do is connect to a public IPF3 server, which in this case I use this one, which is the pin.online.net, and I'm using the port 5209. I'm gonna start using without the UDP just to make sure we use the TCP first, and instead of 1000 megabytes, we're gonna use a 10 gigabytes. So again, what this is doing is it's going to connect to a public IPv3 server in the 5209 port, and it's going to have a bandwidth of 10 gigabytes. And this is a TCP performance test. So we see that we have kind of like a mismatch between whatever the sender like actually send and also what the receiver like receive. So we have that we lost almost like 1 megabyte. So we do the same thing, but instead using UDP. So it's saying that the server is busy. So in this case, we just change the port until we find one that is not busy. And we keep going until it's not busy. A bit more. No. There we go. Nice. So again, in this case, I had trouble connecting with the different ports. So I connected with the 5203 using the UDP performance test. And as we can see, I didn't lose any data from it. I did have some jitter from the receiver end of a jitter of 562 milliseconds. And also, we can see that the transfer rate is also very different from the sender and the receiver. So again, this is just tools that we can use to measure performance tests with different kinds of protocols using TCP or UDP. And yeah, so this was all for the project. And yeah, thank you for seeing the video.